Hi class, good morning. Welcome to our Week 7 topic on Information Management 2, the basic concepts of database normalization, the first normal form to up to the second normal form rules. The topic objectives for this week discussion is to identify the rules in first and second database normalizations and use the first and the second database normalization rules. The database normalization. If we say database normalization, this is a technique of organizing the data in the database. So normalization is a systematic approach of decomposing the tables to eliminate the data redundancy or the repetitions and the undesirable characteristics such as the insertion, the update, and the deletion anomalies. It is a multi-step process that puts data in a tabular format. So removing all the duplicated data from the relation tables. So the normalization rules divides larger tables into a smaller tables and link them using the relationships. Plus, the purpose of normalization in SQL is to eliminate the redundant or the repetitive data and ensure that the data is stored in a logical manner. So the database normalization was proposed by Edgar Code. Given the relation schema, we need to decide whether it is a good design or whether we need to decompose it into a smaller relation, such as the decisions that must be guided by an understanding of what problems, if any, arise from the current schema. So normalization rules used to provide that guidance. So the several normal forms have been proposed, and that normal forms is based on the first normal form, the second normal form, the third normal form, and the Boy's Code normal form, together with the fourth normal form. So these forms have increasingly restrictive requirements, meaning that every relationship in B, C, and F is also in the third normal form. So every relation in the third normal form is also in the second normal form. And every relation in the second normal form is in the first normal form. So a relationship is in the first normal form is there if there are fields that contains only an atomic values, and that is not list of a or a set. So meaning the requirements is implicit in our definition of the relational model, wherein the second normal form is mainly of the historical interest. The third normal form and the B, C, and F are important from the database design standpoint. So what are the problems without normalization? So usually we have the data redundancy, the insertion anomalies, the deletion anomalies, and the update anomalies. So if we say data redundancy, this is a condition as defined by Technopedia. It is a condition that created within a database or data storage technology in which the same piece of data is held in two separate places. And then we have the insertion anomalies as described by fandom.com. It arises when it is not possible to insert important data in the database because other data weren't already there. So in the insertion anomaly, so let us assume that a new department has been started by the organization, but initially there is no employee appointed for that department. And then the tuples from this department cannot be inserted into this table as the number will have a null value. So this is not allowed if uh, e number is a primary key. So for example, if a system is designed to require that a customer be on a file before a sale can be made to that customer, but you cannot add a customer until they have bought something, then you have an insert anomaly. If we say deletion anomalies, these arise when the deletion of unwanted information introduces or induces the deletion of the desired information as well. So let us now consider that there is only one employee in some department and that employee leaves the organization. Then the total of the employees has to be deleted from the table. But in addition to that, information about the department also will get deleted. So this kind of problem in the relation where deletion of some tuples can lead to the loss of some other data that are intended to remove, which is also known as the deletion anomaly. So, for example, if a single database records contain information about a particular product along with the information about the salesperson for the company, and the salesperson quit, so the information about the product is deleted along with the salesperson information. How about the update anomalies? This is arise when the person charged with the task of keeping all the records current and accurate is asked. So meaning, for example, we have to change an employee's title due to a promotion. So if the data is stored redundantly in the same table and the person misses any of them, then there will be a multiple titles associated with that employee. So the end user has no way of knowing which is the correct title. So that is the update anomalies. The first normal form. So there are 4 rules that we need to follow in first normal form. So each column of the table should be a single valued, which means they should not contain multiple values. So we will explain that with the help of an example later. So let us see the other rules for now. The second rule is the attribute domain should not change, meaning the value stored in a column should be of the same domain. So this is more of a common sense rule. So in each column, the values stored must be of the same kind or type. So for example, if you have a column, DOB, to a save date of births of a set of people, then you cannot or you must not save the names of some of them in that column along with the date of birth of others in that column. So it should hold only the date of birth for all the record rows. The third rule is have a unique name for attributes or columns. So meaning that all columns in the table should have unique names. So this rule expects that each column in a table should have a unique name. So this is to avoid the confusion at the time of retrieving data or performing any other operations on the stored data. So if one or more columns have the same name, then the database management system will be left confused. Next, we have the rule number 4, which is order doesn't matter. So this rule says that the order in which you store the data in your table doesn't matter. So in our example, this table is not in the first normal form because the product description column cannot contain the multiple values. So to bring this table to a first normal form, we have to split the table into two tables, and now we have the resulting tables such as the table product price and the table product list. So that is example number 1. So to change the given TBL products into the first normal form, we have to divide the TBL products as TBL product price and the TBL product list. Next, the next example of the first normal form should not eliminate redundancy, but rather uh, is that it eliminates the repeating group. So an example, the table vendor is a multi-valued attribute, so it is not in a first normal form. So its decomposition or conversion into the first normal form have shown in the table such as the table below. So we have to do the repetitive value such as in die. We separate in die into records such as Atis and Apple together with Lily of Santol and Apple. So that's how we convert the table into a first normal form. How about the second normal form? So there are only two. First, the table should be in the first normal form. And then the second one, single column, primary key, or should be no partial dependency. So what is partial dependency? Partial dependency is where an attribute in a table depends on only a part of the primary key and not on the whole key. So what is a partial dependency? So we should not worry about it. So first, let us understand what is dependency in a table. For a simple table like table student, a single column like the student ID can uniquely identify all the records in the table. In our example, we have the table subject, and then we also have the subject ID that identify uniquely the records in a given table. But it is not true all the time. So now let us extend our example to see if more than one column together can act as a primary key. So let's create another table, such as this one, the table for subject, which will have the subject ID and the subject name fields. And the subject ID will be the primary key. So now we have a student table with a student information and another table subject for storing the subject information. How to remove that kind of partial dependency? There can be many different solutions for this, but our objective is to remove the teacher's name from the score table. So the simplest solution is to remove the columns teacher from the score table and add it on the subject table. So hence that the subject table will become the this one. And our score table is now on the second normal form with no partial dependency. So in this example, we have the table score. We have to change it in the first normal form. So we have the subject ID, and then we have the subject name, which is the e-commerce database 2 and techno. The teacher is e-commerce teachers, database teacher, and techno teachers. And our table score is now on the second normal form with no partial dependency based on the tables mentioned above. In the second normal form, so in this example, the course fee alone decide that the value of course number or course no and the student no. So the course fee together with the student no cannot decide the value of the course no. So the course fee together with the course no cannot decide the value of the student no. Hence, the course fee would be a non-prime attribute as it does not belong to the one only candidate key such as the student number or student no and the course no. But of course, the course no and the course fee is dependent on the course no, which is the proper subject of the candidate key, and that non-prime attribute, the course fee, is dependent on the proper subset of the candidate key. So, which is also a partial dependency. So, this relation is not on the second normal form. So, to convert the above relation to the second normal form, so we need to split the tables into the new tables. So, we have to remember that the second normal form tries to reduce the redundant data getting stored in memory. So, for instance, if there are 100 students taking the C1 course, we don't need to store it fee as 1,000 for all the 100 records. So instead, once we can store it in the second table as the course fee for C1 is 1,000. Sample number 3, we have the given table such as students with the ID students, the student name, the ID prof, the prof name, and the grade. So to convert the given table or the student table to second normal form, we need to split the table such as the students, wherein it has the ID stud and the student name, the professors such as ID prof and the prof name, and grades, which is the ID stud, the ID prof, and the year level. So that's how we convert the table into the second normal form. So we need to split the given table and follow the rules mentioned. To summarize our lecture for today, if we say database normalization, it was a theory proposed by Edgar Code, which eliminates the data redundancy and characteristics such as insertion, update, and deletion anomalies. It has different forms such as the first normal form, the second normal form, the third normal form, and the BCNF, and the fourth normal form. For further readings or studies about normalization for first and second normal form, we have to visit, or you need to visit, these references. Thank you.